All right, welcome. Thank you all for making it to the last session of today. I guess everyone is looking forward to get some Belgian beers. But yeah, first of all, let's take half an hour to learn about OpenTelemetry. My name is Dennis Kieselhorst. I'm a solutions architect at AWS. So in my daily work, I help customers transforming their business by leveraging cloud services and building great cloud-native architectures. And there are always multiple combinations. And as a hobby or as a side job, I'm really keen about open source. I'm a committer at Apache Software Foundation. And that's how I got to OpenTelemetry as well. So I found it as an open source project and just like to share with you today what you can achieve with that. So what's the challenge? So the challenge we'd like to solve is we want to find the needle in the haystack. And when I started as a software developer, it's almost 20 years ago, when I started developing Java, we had really large applications, monolithic in nature. It was kind of easy to find out if something went wrong because you just did a tail on the log files, and then at some point the error appeared. Nowadays, everyone is telling we need to get to smaller units like microservices, self-contained systems, or overall also considering software as a service. So putting in third-party components into our architecture as well. So everything is getting more complex and more distributed. And the question is, if something goes wrong, how do we find out where to look into? And as this is a beginner level session, I hope it's not too boring for you, but we do it really quickly to look into the foundations of observability and what is observability at all, before we get into the specifics for OpenTelemetry and then also look into a live demo. So oftentimes my customers tell me, if I ask them what they are doing to find the needle in the haystack, yeah, we have monitoring in place. So if something goes wrong, we get an alarm somewhere, someone gets paged, and then this person gets into it, analyzes it, and then fixes it. Isn't that enough? Or why is observability different from monitoring? And monitoring just indicates, is it working or not? Like green light, red light, while observability tells you why it isn't working. And we want to efficiently detect, investigate, and remediate. And if it's the first time you hear about that, detect is really detect the issue as soon as it begins. You don't want your customer to call you telling you, hey, there's something wrong. You want to be proactively informed about that. That's detection. So that allows you to respond quicker. The sooner you get notified about the issue, the earlier you can fix it. Investigate is where most of the people are losing a lot of time because it takes some time to cut through the chaos. And if you have lots of services involved in your request call chain, for example, it's not always that easy to figure out what's happening. And we want to keep that time short. That's the goal here. And we definitely need some telemetry data to be able to do that. And the last piece, after you've investigated and you found out what's going on there, you want to remediate it, ideally in an automated manner, roll out a patch or roll back a change that you've previously made. But what's also included here is you want to run an analysis to ensure this issue does not happen again. What do you need for that? You need three things given here. You need logs, metrics, and traces. So ideally, the combination of all of those telemetry data here. I start with logs. That's for hopefully well known for most of you. Logs is just timestamp data, and it can be structured as well. That's what you see here should just indicate it's not just line by line. You can structure it in JSON format, for example, to just put in some more data or some structure into log files. Metrics, also several people have seen that, are numeric values. So like CPU usage or disk usage, for example. If you see you are at 95% of disk usage, you can estimate at some point you will hit the 100%, and that's probably not what you want to. So you have regularly sampled data with timestamps, and you can visualize it like I did it here as a Grafana dashboard. So you have some drawings and some graphs that gives you an indication. So you get an idea of how the health of the system is doing. Metrics on the traces, on the other hand, compared to metrics and logs, are not system-centric. Traces are user-centric, and that's why they provide the most value. But unfortunately, many folks have implemented logs and metrics, and just a few have implemented tracing. Tracing really traces cover a request path from a user perspective. So the user targets a request to a system, and you see the path that is traversed by the user. So if you have multiple services, the trace covers all the services that are involved in the user interaction. So they are kind of logs in a context across distributed systems. So, and if you are now agree, okay, yeah, nothing new for me, sounds really great. We want metrics and traces as well. We have logs because our applications have logging configured already. What do we need for that? And you may want to consider this large cloud-native landscape, so lots of tools on there. Even on this large cinema screen, you can't figure out what's written there. Luckily, there are some sections, and one section here is observability and analysis, and we can zoom in, but still a lot of icons and difficult. What could be the tool that we use? Is there the one tool that solves all my problems? And a survey recently turned out, so 2 years ago, the foundation, Cloud Native Computing Foundation, they did a survey, End User Technology Radar, which means they asked multiple companies, hey, what are you doing inside the observability space? What are the tools that you are using? Is there the one tool that is really a good choice? But it turned out there is no consolidation. Most of the adapted tools are open source, but there is no consolidation. So many companies are using multiple tools. Half of the companies are using 5 or more tools, and a third of them had experience with over 10 tools in that space. Which means it's unlikely, as so many tools are already in place, that there will be the one tool that solves it all in the future, and that this is a go-to tool for observability. We need a way to combine the different tools and also to combine different landscapes, and also considering that there may be things already implemented in place, and while standardizing observability, we don't want to modify all the existing stuff that we already have. And this is where OpenTelemetry comes into play. So OpenTelemetry is not that one tool that solves it all. It's a framework that allows you to combine existing things. That's the one to take away. So you get APIs, you get SDKs, and you get some tools that support OpenTelemetry, but it's not observability tool. OpenTelemetry itself is not a back end where you can put in your observability data or something like that. So it's enables you to instrument, to generate, to collect, to export the telemetry data, but it's not living inside an hosted OpenTelemetry instance or something like that. So that it's not. But it's a standardized layer in between. So you get libraries, you get agents, you get components that help you to manage and debug your application services across multiple languages. And that's really powerful because you see here are some languages listed. So Java, for example, I do a lot of Java, and the demo is also in Java, is really well integrated. And the other good thing is it also integrates with libraries. So imagine you have a database driver. You don't want to modify the database driver to be able to track down queries that you do to the database. You want that the library itself supports it. And that's the case for many libraries. So there's already OpenTelemetry support. That means if you plug it in and you enable it, you directly get the trace data generated. So that's really important to take away. It's not an observability backend. It's not there to replace Prometheus or other tools that you know. It's really an open source tool, a pluggable architecture to combine different formats and protocols. And the reference architecture looks like this. So you see in the middle, let's start in the middle, we have two backends. And those backends are the tools that you may have already in place or that you potentially select in the future, like Jaeger, Prometheus, maybe also New Relic, Splunk, or another commercial tool. Doesn't really matter. This is where your observability telemetry data ends up. And on the left and on the right-hand side, you see two applications. And then you also see a collector in different places here. So let's start with the applications. So inside the applications, you have an OpenTelemetry library, which is a standardized library that allows you to generate certain data, for example, metrics, or you want to start your trace, then you can do that using the OpenTelemetry library. You don't have to, by the way. We get to that later on. If you don't want to modify it, you don't have to, but that's one way to do it. You include a library inside your Maven or Gradle file, and then you have it as part of your application. And then the data that gets generated using the library needs to flow somewhere. And to do that, we have the OpenTelemetry collector that lives outside of the application. It can be deployed on the same host. That's one on the left or on the right. Can be a sidecar, for example, if you are doing containers. That's one way to deploy it. Another deployment scenario is to deploy it independently as a service living somewhere else. So those are the two different deployment models. Always depends a bit if you are in a greenfield scenario or you have existing things already in place and how many applications are involved there. But those are basically the scenarios. It's quite flexible. And then the collector allows you to configure, I'm receiving telemetry data from somewhere, where should I forward it? And you can even do it to multiple backends and decide it for each of the signals, so for logs, metrics, and traces individually. If we get back to logs, metrics, and traces, it's important to know that the OpenTelemetry project has a different status for each of the pillars here. So traces was the first thing that got started in the project because the whole project evolved from open tracing and open census. Some of you may have heard it. Those were the previous projects that got merged into OpenTelemetry. So it was the obvious thing to start with tracing. So it's pretty mature. Both API, SDK are stable, and the protocol itself is also stable for a long time now. And I'd really say this is production ready. Metrics depends a bit. So API and protocol are also stable, but looking at the SDKs, depending on the programming language that you want to use, it's considered to be mixed right now. And logs is the newest addition, probably needs to wait until next year before you are able to use it in production. So there's the protocol is stable, but API and SDK are in draft, and currently there's heavy development going on. So I'd not suggest to use that right now. Focus on tracing or metrics if you want to try it out. So and for the demo today, I'll focus on tracing because that's as I said in the beginning, that's the most useful because you cover it from a user perspective. You have different services involved, and that's something that usually many participants in my talks have never touched. Before we get into the demo, just one last thing that you need to understand. Some words about that. So we have the trace on top. As I said, that's covering the whole thing, the user interaction, the request path across the different services. And below that, we have some other things that I just want to tell you so that you know them. At the bottom, you see some sample architecture. There's the user on the left. There's request-response pattern to a front end. Next to the front end, we have an API gateway. There's some function code, and in the end, something is done with a database or a different service. That doesn't really matter. Important is that you have different pieces that are involved into the user interaction. And those pieces, those parts of the trace are called spans in the OpenTelemetry wording. Then there are tools like AWS X-Ray, which also is a tracing tool, and there are other tools on the market that were in place before OpenTelemetry came, and that's why you will find some different names for certain pieces there. In X-Ray, those spans are called segments. Or subsegments. So not that you are confused by the different names, it's just because the spec came later than some of the tools, and that's why there's the same name for a different name for the same thing. So a trace consists of spans or segments, and a span can be combined out of other spans as well. Good. I have it written here. I share the slides later on, so in case you want to read it up, it's also on there. And now we get into some demoing. The code is on GitHub, so if you want to try it out later on, there's also a workshop with instructions. We were running another workshop today. This one is similar, so you can set it up in an account of your choice and then walk through and experiment a bit. What is this demo about? So we often deal with pet stores, and I brought a pet store today as well. And what I can do in this pet store is I can just adopt the pet if I want to adopt this pet. I pay a small fee, and then I can check it out. Thanks for adopting me. And I can just go back to the main page and just look through the list of pets with my kids. I can search here. I can search for puppy, for example. Then I get all the puppies here. I can search for kitten, and I can search for bunnies. Oh, that's taking a bit longer, so can be the Wi-Fi, so we just try it again to see if it's a one-time effect. Kitten, bunny. So it's still slow. So imagine I'm now tasked to analyze why this is taking so long. Why is the search for bunnies taking longer than the search for all of the pets or for kittens, for example? And yeah, what am I doing? I try to look into my observability data, and in this case, we've already set up everything so that the observability data in the end flows to an observability backend, and I used X-Ray in this case. So let me just show you how it looks like. So overall, if you go in here, you see, and this is not specific to X-ray. You find it in other tools as well. So here you find the landscape of all the services and the pieces involved into the architecture. And you see, we really like to create a complex demo. So behind those really simple pet store, there are a lot of different components for demo purposes. And at some point, I want to figure out why the search is slow. So in case I have no idea, I can just go through here and see if I find anything. Maybe it's a database that is suspicious, but overall, a good entry point is potentially the component that's named pet search. And I go in and just view the traces for pet search, and then I get the raw data of all the traces that are collected. What I do next is I just sort it by response time to see, what are the outliers, what's taking long response time, and I see here we have some with 3 seconds. I did several searches, and the age is 1.6 minutes ago, so that's likely a candidate. And if I go into the details of that request, the map gets even simpler because now I'm just seeing the components that are involved into that particular request. And we see it like that. There's a client targeting the pet side, which is the front end. Then I have the pet search. In this case, the pet search is deployed as a container. So there's a container running somewhere with the pet search service. We have a database table next to it, and we have an S3 bucket as an object store, maybe for the images. And that's it. So those were the pieces involved into the search interaction. And down here, you see the spans that are part of the trace. So those lines indicate the length of the execution time, and you see overall calling the pet search API here took 3 seconds. And now we want to analyze, is it the database where we were losing the time, or where did it happen? But we see here DynamoDB, which is a database, is just a small piece next to it here. So seems like it's not the database. Have to be in the application code. And here's something given like search controller search, which sounds likely like a method somewhere in my code. I can also open the subsegment or the related span to search controller search. And I see, if I go here, this has been instrumented with OpenTelemetry for Java in the version 1.17. I see some information on where this is deployed. I also see some other things like the Java thread name, HTTP NIO 80 exec 44, and the thread ID. And if there would be an exception, I would see it here as well. So what are we doing next? Now we figured out it's likely in search controller search. We take a look at the code. And I have it somewhere here. So here, this is the code. As said, that's on GitHub. So in case you want to investigate, you can go in there as well. And we just go to the search method. Search, wrong here. Search, bad typing. Here it is. So here we see get mapping API search. It takes pet type, pet color as parameters. So that's likely to be it. And yeah, what's that? Someone put in a delay of 3 seconds just for demo purposes to display how that works. So but this could likely have been a bad algorithm inside my business logic as well, and the trace data would have helped me to narrow it down and to check what area of my code to look into. So some other important things to see here is here we see there's a tracer span builder, something like that, starting the span. And you may wonder, okay, do I need to pollute my application code with those kind of nasty tracing calls? No, you don't. It's really one option to do it. So in case you want to add specific things to the trace or calling it like that, you can do it. But what you also can do is just doing it using an annotation. And I have some example here. So you can also annotate the method with add with span, and you'll achieve the same. That's another option. And if you even don't want that because you think, okay, if I do that, I have all the OpenTelemetry dependencies and imports in my code. Ideally, I don't have to use these dependencies at all. You can also achieve it. There's a Java agent that you can plug into the JVM, and then you can configure it from the outside. So no need to touch the application code. And so if you are not fully into the DevOps world, for example, and you are an ops guy and you just want to instrument an application, you can do it without even touching the application code by using the OpenTelemetry Java agent. So those are just three options to instrument it. And that should be it for a quick demo. Let me just tell you something more about the. I think that's. I just have some links here for manual instrumentation and for the auto instrumentation with the Java agent. So you get the slides later on. I want to tell you some more things around the collector. We saw it in the reference architecture in the beginning, and the collector is really a powerful tool because you can configure the different aspects, and you really have the possibility to define different receivers and exporters. So in my demo case, I just exported the stuff to X-ray, but I could have exported it somewhere else as well. And as a receiver, I can also define existing other things besides what I'm already using. So it doesn't need to be OpenTelemetry. I can also feed in something that I may have already in place, like if I'm using Zipkin, for example, and the people have selected Zipkin 5 years ago, and now I want to standardize it, I can also feed it into the collector and use the collector as a standard way of dealing with my observability data flow. That's really something you should keep in mind. It can look like that. I have on the left side different observability things, and on the right side I have different things as well. And then I use a collector as a flexible thing to combine everything in a standardized way. Yeah, that should be it for the collector. Just one last piece. There are distributions for OpenTelemetry, and oftentimes I get asked, okay, is it now an AWS flavored OpenTelemetry? Have you patched it somehow that it's a specific AWS flavored distro? And the answer is no. It's fully upstream first distro, so there's no specific thing in it that you will not find on GitHub. We just make it easier so that it works easy together with all the AWS services like X-ray. And it's also backed by AWS support. So in case you have questions, we take care that the specific release is tested and contains all the necessary parts that you need. So in case you want to use it with AWS, you can reach out to us as well. Good. So half an hour is really not that much time, but I saved at least 2 minutes for 2 or 3 questions. So yes, please.
So you can use a Java agent to instrument it. Could you also use something like eBPF, so the Berkeley packet filter in the Linux kernel?
Yeah. So the question was, we can use a Java agent to instrument it. Can we also use eBPF, right? So within Linux. I don't have experience with that. I've not seen related examples, but sounds useful. I'll just take it and take a look afterwards.
Okay, thank you.
Other questions? So I see People are looking forward to end the day. Thanks for joining. Thanks for attending the session, and have fun at DevOps. Will be a great week. Thank you.